Okay, so in this presentation, I'm just going to run through an example using the RRAM method just to point out some things. Here is our function definition, 1/4 x squared plus 2. This is the interval that our function that we're looking to approximate the area for. So if we were to look at this graph, we're going from 0 to 2. This is the area that we want to approximate here. And we're going to approximate this area using 4 rectangles, and more specifically, right rectangles, meaning that we use the right endpoint of the rectangle. So if we look at these rectangles, it is the right endpoint of the rectangle that we're using to determine the height of this rectangle. And then we go to the next rectangle on the right side. We're using the right endpoint of the base until we hit the curve. That gives us the height of the rectangle. And then the next right endpoint until we hit the curve. That gives us the height. So that's the technique that we're using, the right rectangle approximation method. So because we see that we're doing 4 rectangles, we can set up our table. We set up our I values, 1, 2, 3, and 4. That's for the 4 rectangles. Next, we want the x position of each of these rectangles. And because it's a right rectangle, we get the x position from the right-hand side. We want to find the width of each rectangle. b minus a over n, which is 2 minus 0 over 4, which tells us each rectangle has a width of 1/2. If we start from 0, that means the first position on the right side is at 1/2. And now when we move to the next rectangle, the position is at 1. And then the next rectangle, the position is at 3/2. And our fourth rectangle, the position is at 2. Next, we would like to calculate the height of each rectangle. And we do that by taking each x sub I value and plugging it in for x in our function. So we want 1/4 times 1/2 squared plus 2 to get our first f of x sub I, which is 2.0625. Then we plug in 1, so 1/4 times 1 squared plus 2 gives us 2.25. And we continue to do this. And then next, the width of each rectangle, that is our delta x. And then to calculate the area of each rectangle, so each rectangle I has its own area, and we get that by taking the height and multiplying it by the width. And this will give us each area of the independent rectangles, which we will then add up to get our total approximation. So 1/2 times 0.20625 gives us 1.03125. 1/2 times 2.25, we get 1.125. And we'll continue to do this. And now we want to add up all of these numbers here. So if we add them all up, we get the sum of all of the areas for each rectangle I, which comes to 4.9375. So that means that the area under this curve to the x-axis is approximately 4.9375.